All right, pre-cal. We are going to talk about evaluating logarithms. So if you will notice here, I'm going to do all of these examples. I want you to notice that in 7 through 14, it's not set equal to anything. So in that case, that means we want to know what it equals. So we're going to have to set these equal to x, and then the very next thing we're going to do is we're going to put them in exponential form, because that way we can solve for what x is. So that's what we'll do in these first 7 problems, or these first 8 problems. Yes, I can count. All right, so log base 3 of 81 equals x. So in doing this, I am going to set, I'm going to put this in exponential form. So this is going to be 3 to the x equals 81. So really, how does that help us? Well, it helps us because 81 can be written in a base of 3. All right, so I can write 3 to the x, but 81 is 3 to the 4th, because I know that 3 times 3 times 3 times 3 gives me 81. Once my bases are the same, I can just set my exponents equal to each other, and then I'm done. Yes, it's that easy. Okay, so the next one equals x, so I'm going to write it in exponential form. So base 5 to the x equals the square root of 5. Well, I've said in other videos, and I've said it in class as well, that anything in the square root can be written to the 1/2. The 2 indicates that this is a square root. So that's how we would write it, 1 over 2. If we had something like the cubed root of 5, that would be 5 to the 1/3. So that's the logic behind that. This means that my bases are the same, so x just equals 1/2. Groovy. Okay, the next one, I'm going to set it equal to x. I'm going to write it in exponential form. Okay, this one, it's a little harder to write 1 over 49 in a base of 7. So what we need to do is we need to get 49 up out of the denominator. Well, we can't change the value of it, but I can change what it looks like. So I can write 1 over 49 as 49 to the -1, and that means the same thing. I'm just writing it differently. So now I can write this. I know that 49 is in a base. I can write it as 7 squared. So essentially it's going to be 7 squared, and then the square gets multiplied by the -1. So I have 7 to the -2. My bases are the same, so I just set my exponents equal to each other. All right, this problem right here, I'm going to set this equal to x. Base 2 to the x equals 2. Well, since it's just 2, this is understood to be 1. So x is equal to 1. Log base 8 of 512 equals x. I'm going to write a base of 8 to the x equals 512. Well, 512 can be written in a base of 8 because it is 8 cubed. So then x equals 3. And don't worry, if a problem won't work out this way, like if you can't write it in the same base, we are going to deal with that later. But for now, they can all be written in the same base. So I'm going to set this equal to x. I'm in a base of 4, so I write 4 to the x equals 4 to the 3.2. It's automatically written in the same base because of the nature of the problem. X equals 3.2. All right, these I'm going to set equal to x, still doing the same thing. 2 to the x equals 1 over 32. This is just like this problem up here, where I've got to first write it as 32 to the -1, and then I can write it in a base of 2 because 32 is actually 2 to the 5th. So 5 times -1 is -5, and then set the exponents equal to each other. Set this equal to x. I'm in a base of 16 to the x equals the square root of 2. Okay, this one's a little trickier, so don't panic. Okay, this one, I'm not, dadgummit, I'm out of control. I know, you're surprised. All right, for this one, I can write 2 to the 1/2, but I can't write 2 in a base of 16. I can't make it bigger than it is. But I can write 16 in a base of 2 because 16 is 2 to the 4th. So what I would essentially have here is 2 to the 4x. Once my bases are the same, then I can set 4x equal to 1/2. because I can set the exponents equal to each other once the bases are the same. And then, of course, I can just divide both sides by 4. So 1/2 divided by 4 is actually 1/2 times 1 over 4. So x equals 1 over 8 here. Beautiful. Okay, let's skip down and look at 15. All right, 15 is a little bit different. These are already set equal to something, so I'm basically justifying these. I'm actually seeing, is this really equal to this? Well, if I write it in exponential form, 32 to the 2/5 equals 4. So is that really true? Well, let's look. 32 to the 2/5 is actually 32 squared, and I'm taking the 5th root of it. Well, the 5th root of 32 is 2. 2 squared, guess what? That's 4. That checks out. Life is good. So this is a true statement. Let's see if this one is. I've got 8 to the 2/3 equals 4. This means the cubed root of 8 squared. The cubed root of 8 is 2. 2 squared, guess what? It's 4. This is a true statement. Natural log x equals 5. Okay, this one's tricky. Remember, natural log is understood to be in a base of e. Remember, e is the Euler number. That's 2.718. So when I solve this one, I have to put it in exponential form because you'll notice we have a variable in this problem. It's not these kinds of problems where we're just justifying it. This one actually has a value we need to solve. So I'm going to write this in exponential order or exponential form, just like I did the other problems. So I'm going to write this as e to the 5th equals x. And in our calculator, we can just type that in, and what we get is we get approximately 148.41. Okay, and then I have e to the x here is 2. Well, my variable is in the exponential form, so it's going to be hard to solve this. So I need to then write it in log form. So log, natural log, base e of 2 equals x. And there's a button on your calculator called ln, which is the natural log. You take the natural log of 2, and you get approximately 0.69. So that's how that works. Okay, now we're going to do these equations down here. Same thing here. If I've got e to the x equals 4, what I really want is natural log 4, and this is approximately 1.39. Okay, natural log x. It's like this problem up here. I have to put it in exponential form, so e to the -1 equals x. I can type this into my calculator, get approximately 0.37. This one, just like this one, just like this one. I'm going to put this in a base of e to the -7. I type that in my calculator. Life is good. Now this one, you get 9.12 times 10 to the -4, so that's scientific notation. This means the same thing. If I were to take this decimal and move it to the left 4, 1, 2, 3, 4, it would look like that. All right, this one, a little tricky. What we want to do is isolate the natural log x, so I'm going to subtract 5 from both sides. And now I'm going to divide by 2. So I get natural log x of -1/2. So then I'm going to put this in exponential form. Type that into my calculator, and I get approximately 0.61. So that is how we evaluate simple logarithms.